So there's always some sort of a battery, and then you've got a resistor 1, and then resistor 2, and then resistor 3. So we'll go 1.7, 0.28, because we want to convert it to volts. You take that 280 millivolts, and there's 1,000 millivolts in 1 volt. And then similarly for resistor 3. Okay. And we've got some equations here. V equals IR. And let's see here. I'm sorry, they're giving you they're giving you the voltage across each. Okay, I see. Okay, let me yeah, I definitely need a reference problem for this. This is not my area of specialty. Physics gets very specific very quickly. Let's see if we can find a problem like this, and see if we can come up with this. I'm just looking here. I'm not finding anything that's helpful at the moment. Let's see what else we can do here. Are you taking this class for high school, or is this like a college prep thing, a college placement thing, or what do you got going on here?
It's a high school thing, so I'm just gonna do this to help because I didn't understand physics last year, so I'm just gonna build on what I
Okay.
learned last year.
All right. Yeah, this is what is the potential difference provided by the voltage source? So 1.7 volts, and then it drops, is this the kind of thing where we can do it more than once to meaning that like how important is the right answer here? Like do you get another attempt, or is this the only one?
It's a practice quiz. It's just to check for your understanding.
Okay.
But I have 2 attempts. It's 4 questions and I can have 2 attempts on it.
Okay, because the what you see here is the voltage does drop across each resistor, so it's going to be its largest at the source, which isn't really the way to do it. But the answer then is 2.1 volts, pretty sure, because it does, and this is for number 3, I guess we're doing, because the voltage has to be highest at the source here, and then it drops and drops a little more before coming back. But let's see what else you got here. Let's see if I'm going to even be able to help you much. Yeah. Okay. We should probably start at question 1 also. That would also maybe be more helpful here. So let me do
Okay.
that. Okay, in a series circuit, each circuit receives equal blank. In a parallel circuit, each circuit receives equal blank. So the answers are it's either current and resistance or resistance and current. So we're gonna this is like basically a textbook thing here. So let me just check a reference here and see if I can come up with an answer for you. A series circuit, each circuit element has the same. So the I mean, this is just a definition. It's current in a series circuit, and that's what we were just showing. Series means that it's there's no what are called branches. Like there's only one path that you can take. That's what a series circuit is. In a parallel circuit, there are multiple branches, so you can like branch. This would be considered a parallel circuit. And that's where there's there's a changes for this.
Okay.
So this is a current and I'm sorry, voltage is the second blank here. So the voltage drops in a and we saw that in this previous problem. The voltage dropped went from 1.7.28 to 0.12. In a parallel circuit, the voltage across each resistor would be the same.
Okay.
And do you get the same questions each time, or are they different?
It's the same questions.
Same questions. Okay. Okay, so let's look at question 2. Okay, so five resistors, 10 ohm each, are connected in parallel to a voltage source. So you got some sort of a source here. You got resistor 1, resistor 2, resistor 3, resistor 4, and resistor 5, and they're each 10 ohms. And then so there's 2 formulas for equivalent resistance. The one formula is you just add them up. The other one is you add up the reciprocals of them. Let me actually get that formula, just double check that. So what you're looking for is the equivalent resistance in a excuse me, in a parallel circuit.
Okay.
So the formula for that is, let me find it. There's a couple of ways that it's sometimes it's written 1 over R1 equals 1 over R1 plus 1 over R2 plus 1 over R3 and so on. And then sometimes they just rewrite it as RE equals 1 over R1 plus 1 over R2 plus 1 over R3. So there's a couple of formulas there for you to look at. So the parallel one is this one here on the right. I'm sorry, the second one. So it's a little more complicated. You have to do 1 over R equivalent, or R total, is 1 over 10 plus 1 over 10 plus 1 over 10 plus 1 over 10 plus 1 over 10. And so if you add all these up, you get 1/2.
Okay.
And then you can cross multiply here, or you just take the reciprocal of the number on the right. So the equivalent is 1/1/2 or 2.
Okay.
So 2 ohms is the equivalent resistance.
Okay.
So I go back to question 1. I guess, okay, now I guess I realize what's going on here. Maybe I'm sorry, question 3. I think I could better answer this. So the we can draw this circuit again if we want to. So you've got a voltage source, and then resistor 1, resistor 2, resistor 3. So they're saying the voltage across resistor 1 is 1.7. This one is 0.28 volts, and 0.12 volts. And the I don't know, the voltage total in the circuit is the voltage of the individual ones. So 1.7 plus 0.28 plus 0.12. And that's where you get your 2.1 volts. It's also the case that it decreases, like I mentioned, in this loop that it goes in.
Mm-hmm.
So the answer there is that I think it's 2.1 volts. Letter C. And then question 4. Question 4 is a little more involved. Let's see here. We're kind of making our way through it. Circuit has 3 resistors connected in series. Okay, the current is measured. Why does this look exactly the same? Oh, I didn't get the answers. That's why. Let me grab those answers. Let me try this again. Okay, so draw our circuit again. Okay, so the current I is 1.4 amps, and we know that the voltage total is 2.1 volts because we just did that in the previous problem. And then V equals IR, that's Ohm's law. You probably saw that in a video or lecture thing.
Mm-hmm. Yeah.
So V equals IR. So what you do is you can solve for R. R is V divided by I. The voltage is 2.1 divided by 1.4. And that ends up being 1.5 ohms.
Okay.
Okay. And so this is where it gets a little bit, I think, confusing. There's 1.5 ohms, I don't know, kind of starting here, call this position 1. And so you have to go resistor by resistor. So at the first resistor, you do this V equals IR again. Okay. And you say, okay, but you don't, how do I say this? You your current is constant, but your voltage is now 1.7.
Mhm.
So I think what do you do here? Do you divide? Yeah, so I think your resistance is your voltage divided by your current at each point in time. So let's see here. 280.28 over 1.4. Let me see if that works out. A little bit of a guess here.
Okay.
So yeah, so that ends up being 0.2, which would be 0.2 ohms or 200 milliohms. And then if you do the same thing at resistor 3, so resistor 3 is the voltage across resistor 3, which we already have, the 120 millivolts, the 0.12 divided by the current, which is constant. So that gives you 0.086 ohms or 86 milliohms.
Okay.
So it looks like it's that.
Okay.
So we can do some more examples of these if you want, but maybe try these answers and see if they're right. And that'll give us kind of a path forward here.
Okay. So we have the first two done for one of them, and then we have the last two done for another one.
So these are not from the same one. I'm sorry.
No, it's two different ones that
Oh,
got
well, that's no
jumbled
good.
together.
Yeah, no, that's not good because I was like, wow, these are really okay. I see. Well, yeah, okay. So maybe for future, um, we'll just do them in the same quiz. So
Okay.
So let's see here. All right, 5 resistors are connected in parallel to a voltage source. Okay, so we already kind of did that where you got your voltage source, and then I always found it frustrating to have to draw this over and over again. But this, if they did want to see your work, that's what they want to see. So if they're 10 ohms each, we did the resistance total. 1 over the resistance total is 1 over 10 plus 1 over 10 plus 1 over 10. So for each of these, because each of these are 10 here.
Okay.
So your resistance total is 1/2. It's 1 over 10 plus 1 over 10. All those is 5 over 10 or 1/2. And so your resistance total is 2 ohms. Okay.
Mm-hmm.
And it says the current at each branch is 600 milliamps. So that's 0.6 amps, which is what we want. We want it to be in base units. So your V equals IR. So your voltage is your current 0.6 times your resistance, which is 2.
Okay.
Except that answer is not there. I wonder. So I wonder, okay, the current at each branch. Oh, so because it's parallel, it's like it splits off. So there's 0.6 at each branch, but you need the total. So you have to add those up. So the total current is not 0.6, it's actually 3. because there's 5 of them. And that gives you 6 volts.
Okay.
Is that okay?
Yeah.
No? Okay. All right, so next question here. Okay, a 2 kilo ohm resistor. So that's no good. Again, like we need that to be back into ohms. So we'll go 2,500 ohms. Should I get an extra 0 in there? You want to quickly convert to the base units. So you got your source, resistor 1, resistor 2, back. So this one's 2,500 ohms. This is 20 ohms. 9-volt source. Oh, they're in parallel. Sorry. So this is the wrong picture. Got to get the right picture. So there's that one. Okay, so 2,500 ohm and then a 20 ohm. So your resistance total is 1 over 2,500 plus 1 over 20. So this is the kind of the shortcut formula where you do 1 over each of them. And just want to be really careful how you put it in the calculator. Make sure you put parentheses down here on the bottom. So I'm going to grab mine, but I would encourage you to try that also on your own. And at some point, the numbers don't work out nicely. I don't know if this one does. This does not work out nicely. So the resistance total is 19.84 ohms. Okay, so now you're like what you're trying to do is you're trying to get this down into like an equivalent circuit, which is 1 voltage, 1 resistor, and then you can use your Ohm's law, V equals IR.
Okay.
And you're solving for current, I this time. So I is voltage divided by resistance. Your voltage is 9, your resistance is 19.84. Uh-oh. Just looking at, doesn't seem like it's going to work out. Maybe it does. 9 divided by 19.84. Oh yeah, it does. So this becomes 400. It's 0.454 amps, which is pretty close to that, 450 milliamps. So they not only have like unit conversions, you have to know your Ohm's law stuff.
Okay.
Okay, so I think we got another question 1 here. Have we done this one yet?
No, I don't think so.
Okay, so they're connected in series, so that's nice. Sometimes you just start drawing them, 5 ohm. Oops, that's your 10, that's your 12. So your 10 ohm, your 12 ohm, and your 16 ohm, and then you just draw your. It doesn't really matter where you draw your voltage source.
Okay.
But this is the one that we should have done first. When the resistors are in series, the total resistance is R1 plus R2 plus R3 plus R4 and so on, like as many as you have. So it's 5 plus 10 plus 12 plus 16. So the takeaway from this is really that you have two types of problems you're going to see in this part of the course: series problems and parallel problems. And certain words, certain formulas like work better in like series versus parallel.
Okay.
So just you want to get like, it's almost like there's two columns of formulas that you need. So anyway, our total resistance is 15, 27, 43 ohms. The current comes from V equals IR. So you often use these combining equations, and then you go back to this. So the current is the voltage divided by the resistance, 120 ohms over the 43, 100 volts over 43 ohms. So 120 over 43, and that gives you 2.8 amps.
Okay.
So question two is related to that one. We'll just draw on the. So there's 2.8 amps in the circuit. So the in each, we found that from the previous problem that the current is 2.8 amps. And so the voltage, you always go back to this equation, V equals IR. You take the current and you to find the voltage, you take the current and multiply it by the resistance.
Okay.
So we've got 2.8 times, and then so for each resistor, so the first one is 5 ohm. So that's 5. And then the second resistor is 2.8 times 10. It's 10 ohm. And we're just using this IR again. IR. And then it's 2.8 times 12. It's for the third one. And then 2.8 times 16 for the fourth one. So it looks like it's this right here.
Okay.
But yeah. It's also possible here, let's look at something else. I can't remember if you have to actually add up the resistances each time. This is where I'm not necessarily the most expert at this. I recall there's a scenario where you have to actually add up the resistances, but that doesn't look to be the case. Okay, I guess I would go with that one, and maybe see. Did we get through all of them now to try?
Yeah.
Okay.
Oh, okay. Those were all right. All 8 of them.
Wow, fantastic. So we could summarize, we can do some more problems like them, go through them again, whatever you would like to do.
Let's see. I think I have 4 more similar ones, but no. Can I send over 3 more questions?
Sure, we'll see what we can get done. We've got another session also, so.
Okay. Okay, I just sent it over.
Okay. There it is. Okay, let's take a look. Try and do these in order this time. All right. All right, so for this first one, I have no idea. I'm gonna go to the web and see if I can find a reference here to help. I don't even know what this means, but so
Yeah, I was confused when I saw that question.
there are for someone that works in this field, they would know this right away because it's probably a well-known thing, but so a fixed, like, what if we take like the meaning of each one, or fixed means that it would be unchanging. A photoresistor is light sensitive, and a thermistor would probably be resistant, would change based on temperature. A rheostat, I should know what that is. I've used those before. Potentiometer. Oh yeah. Have you already answered these ones?
No, it just came like those. Those were like the default.
Okay.
When I opened
The
it.
reason I'm asking is because if you've already tried one, that could maybe help here. Just do a quick check here. So I know for sure I would say no and no. So that's where I was going with this is I would probably try this first and then this second if I were working through that. I can do a little bit more looking here. Rheostat's not really a resistor, but it's in this problem. So that's probably the best I can do with this one. Is I'd probably try none of these as an answer.
Okay.
But let's keep going here. So, oh, there is. How can the resistance of a potentiometer be adjusted. So the way a potentiometer works is you literally, you've got a couple, like two wires. You got a plus wire and then a minus wire, and you got your box.
Mhm.
So generally, like there's a toggle on here with different like switches for adjusting the resistance. So to me, I would say manually, because you're manually like moving this knob. It doesn't have anything to do with temperature. Does not have this. It does have there is an AC DC setting. So alternating current is AC and direct current is what's called DC. And they do have settings for those on these devices. So I guess I would go 1 and then 2 if I were guessing on those. It's odd. Have you okay? So I mean, there's so much available on the web. If you literally copy everything, starting down here all the way up, I'm surprised you didn't get a full hit on this question. You may try that in the future.
Okay.
But let's see here. And then I guess question 3, or this, what is it? Is the 2 independent circuits, or the let me just snip it in here. Okay. Okay, so you got this picture. And so what I would do is to answer a question like this one is I would look in my book, or I would go out to the web, and I would look up each of these and do a Google image search on them, which maybe you already did, but we're looking for the sort of the like standard symbol for these. And see if I can find one here. Huh. So the thermistor actually doesn't necessarily have like as similar as I thought it would be. The thermistor, that's this one here. I think you've got one like that on your
Yeah.
and so you've also got this one where, oh yeah, yours has got a T on it. So yeah, this is B for sure. Your light dependent resistor is A. Yeah, you got these all right, actually.
Oh, okay.
So they're all right. Those are all good. And then you have this other question, which grab here. So this one is either it's one of these two answers. I'll tell you that right off the bat. And I guess it's the way the photoresistor works. I don't know whether intrinsic or extrinsic means that it would have a higher or a lower current. Do a quick search on that. Mm. Well, I'm not, I would recommend, we'd have to pick this up with the next lesson, or you could just go one or two on these, choose one and then the other.
Okay.
So we can wait an hour, or we can do, or we can do it in like 15 minutes. Do you have a preference for doing the next lesson?
I can do either.
Okay. Can I just send you a message through text in about 1 minute?
Yeah.
All right, I'll get back to you. Thank you very much.
Yeah, thank you.
Okay, bye.
Bye.